Hi everyone and welcome back. In this video I'm going to be showing you how to solve an equation that has variables on both sides of the equal sign. So I'll get everyone to take out their Solving Linear Equations foldable and open it up to the very last section that's labeled Solve Equations with Variables on Both Sides. So you can open that up and then I'll get you to start writing at the very top. And here's what you're going to write. To get the variable alone when you have variables on both sides of the equal sign. You must start by moving them to the same side. Using addition or subtraction. Okay, so in order to move the entire term, you're going to be using addition or subtraction. So I know that you're used to, when working with a term that has a variable, you're used to using multiplication or division to cancel out the coefficient or the divisor. But in this case, we're not just trying to cancel out the coefficient or the divisor to get the variable alone. In this first step, we're actually trying to move that entire term over. So in order to move the entire term, we have to use addition or subtraction. So let me show you, using an example, exactly what I mean. So just so you know, we will be putting 3 examples in this section, but for this video, we're just going to focus on example 1. So here's what we've got for example 1. 0.4x equals 5.58 minus 0.2x. So this is what I mean by an equation with variables on both sides of the equal sign. So as this stands, we are not going to be able to get x alone, pardon me, because it's in 2 places. So we have to move it over to the same side. Okay, so when you have an equation like this where there's only 1 term on the one side and 2 terms on the other side, okay, move the variable term from the side with 2 terms over to the side with only 1 term. And like I already said, the way we do that is not by using division, because we're not just simply trying to cancel out this numerical coefficient here and get x alone. We're not there yet. We have to group all of these x's together before we get there. So the only way that we can move this entire term over is using either addition or subtraction. And it's still opposite operations. So right now, this term is being subtracted. So what's the opposite of subtracting 0.2x? Adding 0.2x. Okay, because when we do that, negative 0.2x combined with positive 0.2x, it cancels to 0. Okay, even though we don't know what x is, we know that both of these x's will have the same value. So ultimately, if we have the same number negative put with the same number positive, it will cancel to 0. So that's gone from there. But then, what do we have to do to the other side? Always the exact same thing. So add 0.2x plus 0.2x plus 0.2x. So now, when we add this, we end up with 0.6x on the left side of the equal sign. And on the right side, all that's remaining is this 5.58. 0.58, right? Because this canceled to 0. This is gone. We actually got rid of it. Okay, we couldn't have done that if we had just divided. All we would have got rid of then would be the numerical coefficient. So to move the entire term, including the variable, we have to specifically use addition or subtraction to do that. So move the entire term. We have to move the entire term. But anyways, once we've done that, you'll notice what we're looking at here now is just a regular one-step equation. I've only got another one step left to actually get my variable alone now. Okay, so right now, because all my x's are in the same place, and right now they're being multiplied by 0.6, so the opposite would be to divide by 0.6. 0.6 divided by 0.6 gives me just one x, a single x. That's what I want. Looking good, but what do I have to do to the other side? Always the exact same thing, divide by 0.6. So I can just type that into my calculator. 5.58 divided by 0.6 equals 9.3. Box it up, nice and neat. Final answer. And that's it, I solved it. Okay, so then the only other thing that I should do is a check. Okay, so we can just put it off to the side here where we have space. And I'll remind you that when we're doing a check, we're back to following regular order of operations, BEDMAS. Okay, and I'm going to copy the original equation out exactly as it is. The only thing I'm going to change is I'm going to replace my x's with the value that I got for x in brackets. So instead of an x here, I now have 0.4 times 9.3 on the left side, and on the right side still have 5.58 minus 0.2, but again I'm going to replace the other x with the value I got for x, 9.3. Okay, so everything about this equation is just exactly as it was originally. I've just substituted 9.3 into the first x and 9.3 into the second x. Okay, so now I'm going to solve to see if both sides of my equation here come out to the same number. Okay, so on the left side of the equal sign, all I have is multiplication. So I'm just going to go ahead and times that out. 0.4 times 9.3 equals 3.72. Okay, on the right side of the equal sign, I've got subtraction and I've got multiplication. So according to regular order of operations, what comes first? Division and multiplication comes before addition and subtraction. So I need to multiply before I subtract. So I'll just bring down what I'm not dealing with right now. So this 5.58 minus, I'm not doing anything with, but I am multiplying 0.2 times 9.3. So that comes out to 186. Okay, so now I'm done with division and multiplication. I can move on to addition or subtraction, in this case, subtraction. So on the left side of my equation, I still have this 3.72, nothing else for me to solve there. And on the right side, let's subtract. 5.58 minus 1.86 equals 3.72. Beautiful. Both sides come out to the same number, so check. I know for sure that my answer of x equals 9.3 is correct. Thank you so much for watching, and I will see you in the next one.